Hi, welcome to our Edpuzzle for Tuesday, September 21st. First of all, please remember guest teacher, respectful. You have an hour, roughly, a little bit less than that. You'll survive. Okay, hopefully everything is going well. Thank you so much. It really means a lot to me that I can do this so I can be with my dad today. Okay, so we still have the same learning objective for today's lesson. It's you will be able to use math to compare and describe likelihoods. Probability, just as a refresher, is the chances of something happening or something not happening. Probability is always between 0% and 100%. It either happens or it doesn't happen, or it's somewhere in between. Another way to talk about that is it's between 0 and 1. That's a quiz question. Just giving you the heads up. Okay. We're going to talk about theoretical probability. So theoretical probability is the probability that should happen based on the information given. So based on just the information, so for example, if we have a spinner that has 40% red, okay, 40% red, thank you for letting me write on this, Salma. If you have 40% red, okay, that means that there's a 40% chance that it's going to land on red, right? The probability of it landing on red, the probability of red, when you have a P next to a parentheses like this, it means probability of red is 40%. Or we could look at it as 4 out of 10 times or 2 out of 5 times, because those are equivalent fractions. Or we could say 40 out of 100 times. We're using the numbers that exist, and we are coming up with a probability that should happen. We're using the theoretical. Theoretical has the word theory in it. And a theory is basically in science or in language arts, in social studies, in any of those, theory means that you're making your best guess based on the information that you have. So theoretical probability is exactly the same thing, but regarding probability. It's the probability that should happen based on the information given. So for the example, since 40% of the spinner is red, the needle should land on red 4 out of 10 times, or 4/10. All right. The other kind of probability is called experimental probability. Experimental probability is the probability of what actually happens when you do it. So for example, if I were to then take this and spin 10 times, what actually happened? How many times did the spinner actually land on red? So the example is the needle actually landed on red how many out of 10 times? Well, let's go ahead and do it. All right, so my hand is going to be in the way a bit. I'm going to do the best I can. I'm going to take my keys off so they stop rattling in the video. All right, so we're going to count how many times it lands on red and any other color. And we're going to do 10 times. All right, I'm going to move my face. Woohoo, moving my face. Ooh, didn't mean to shrink me, but I did. Okay, I'm moving me over here. How's that? Woo! All right. Right there. Trying to make most of it show. It landed on blue. There's our first spin. It landed on blue. Landed on blue. Landed on red. So remember, we're checking our experimental probability. Red. Green. Red. Did I do that wrong? Red. I feel like I might have done something wrong. That's okay. Other color. Let's see, I'm at 1, 2, 3, 4, 5, 6, 7, 8. I got 2 more spins. red, red. So in this case, it actually landed on red 5 out of 10 times, and it landed on another color 5 out of 10 times. So we've got 5 out of 10 times is what actually happened. So that would be a fraction of 5/10, or that could be simplified to 1/2. Or we could say it landed on red 50% of the time. Oops, you can't see that. I'm sorry. There you go. So it landed on red 50% of the time, because 5 out of 10 times it landed on red. All right. So that's experimental probability, is what actually happened. Okay, we're going to do some practice. By the way, B's on your quiz, being able to explain the difference between the two. All right, so as I said earlier, when you have P, the letter P is probability, and if you have it right next to a parentheses, it means what is the probability? What is probability of blue? This is math shortcut to say what is the probability that will land on blue. Well, theoretically, we've got 30% is, there should be 6 here, 1, 2, 3, 4, 5, 6. It's a 30% chance. So it's a 30% chance that it's going to land on blue. So what is blue? It's 30% chance, which means 3 out of 10 spins should land in blue. That's our theoretical probability. Let's see what our experimental probability is. So here's blue, and here's all other colors. Red. What do you think is going to happen? Red. Blue. Red. Oh. Blue. Poor green and yellow, not getting any love at all. Red. Yellow. Oh. Red. Let's see, that's 6, 7, 8. I got 2 more spins. Green. Blue. So what actually happened? What was our experimental probability? Well, out of 10 rolls or 10 spins, it landed 3 out of 10 spins. So in this case, our experimental and our theoretical ended up the same. Do you think that every time our experimental is going to be exactly what it was supposed to be? Probably not. It's very unlikely. The probability of that happening every single time is so slim. It's actually impossible for it to happen every time. All right. Probability of yellow and green. So with the yellow and green, yellow is 2 out of 10. Green is 4 out of 10. So that means green and yellow is going to be what? Yeah, it's going to be 6 out of 10, or 60% chance of landing on green and yellow. Excuse me. So we are going to now do the experiment of green and yellow. Green and yellow, and this would be blue and red. Hold on, my brain is, oh, wait. I see what I did. I was like, that's not right. It's 2 plus, it's 6 out of 20 because it's 6 out of 20 total, not 10 total. So to find out what the percentage is, it would be 6/20. So we could either use the giant 1 to divide to get it down to 10 and divide by 2, so 3 out of 10. Or we could use the giant 1 to multiply to 100. 10 times 10 is, 10 times 5. Ooh, I keep messing up on this one. 10 times 5, 20. Oh, reset. All right. So 6 out of 20 tries. 6 out of 20 of these are colored yellow and green. So 20 times 5 equals 100. 6 times 5 is 30. So it's a 30% chance or a 3 out of 10 chance. All right. So we're going to go ahead and give it a try. Oops, let me actually spin it. Blue. Yellow. Yellow again. Green. So we're getting our experimental probability, blue and red, yellow, red, 3 more spins, oops, blue, red, that's 5, 6, 7, 8, 9, 1 more. Yellow. So what did we actually end up with? This is 1, 2, 3, 4, 5. I'm making sure that I got 5. I just forgot to cross it over on that last one. So we actually hit green and yellow 5 out of 10 times. So our experimental probability is greater than our theoretical. In this case, they were equal, right? For the blue. But this time, our prediction, our theory, based on the numbers, was 30%. This time, we're at 50%. We were 50% green and yellow. Just works out that way sometimes. Okay, last one. Well, kind of last one. What is the probability that we'll land on pink? Theoretically, there is no pink. There's a 0% chance. It's impossible to land on pink because there is no pink. Our experimental, what's going to happen? I'm going to spin it 10 times. Is it ever going to land on pink? Nope, it is not. So our experimental is also going to be 0%. All right. Last question. What is the probability that Mrs. Verity returning tomorrow? Because I'm not here today. What's the probability? Now we can't do the experimental because we can't do it on paper right now because we can't experiment right now. It's today. It's not tomorrow. You can find out if I show up tomorrow or not. What do you think is the probability that I will show up tomorrow? Do you think there's a 10% chance, like a 10 out of 100 or a 1 out of 10? Do you think it's 25% or 25 out of 100 or 25%? What is the probability of Mrs. Verity returning tomorrow? What do you think? You can write it as a fraction or as a percentage. You could even write it as a decimal. So there's a 0.1 chance. That's the same thing as those. A 0.25 chance. That's the same as those. All right. That is the lesson. Please make sure you do this all the way through, and then you are working on the class kit. Thank you for your attention. Bye.